Today we're going to cover pages 4 and 5 of our Chapter 1 notes packet. All right, so starting on page 4, we're going to look at absolute value inequalities. For example, we want to find the solution set for the absolute value of 2x minus 3 greater than 7. The steps for solving an absolute value inequality: first thing, isolate the absolute value part if it's not already isolated. Make two arrows, a left arrow and a right arrow. On the left arrow, you remove the absolute value bars, switch the inequality symbol, and negate the number on the right. For the right arrow, you remove the absolute value bars and copy everything as is. If the inequality is a less than or equal to, write an and between the left and the right. If the inequality is greater than or equal to, write an or. For example, so solving the inequality, the absolute value of 2x minus 3 is greater than 7. Left arrow, drop the bars, switch the inequality symbol from greater than to less than, and negate the 7, so we have negative 7. It's a greater than symbol, so we write the word or. And for our right arrow, we drop the bars and copy everything as is. So 2x minus 3 is greater than 7. Now we continue to solve. Add 3 to both sides. 2x is less than negative 4. Divide both sides by 2. X is less than negative 2. Add 3 to both sides. 2x is greater than 10. Divide by 2. X is greater than 5. So our solution to the above inequality is x is less than negative 2 or x is greater than 5. Now, solutions can be represented 3 different ways. Symbolic form, that's using the inequalities less than or equal to, greater than or equal to. Interval notation, close bracket, is for less than or equal to and greater than or equal to. The open parentheses for less than or just greater than. And then infinity for greater than or equal to and greater than, and negative infinity for less than or equal to and less than. And the third way is graphically on a number line. Filled in circles for the equal to part, less than or equal to, greater than or equal to, and open circles for simply less than or greater than. So the solution in symbolic form from the above absolute value inequality we have written already. That's x is less than negative 2 or x is greater than 5. Using interval notation, I'm going to do that for last, and I'm going to graph the solution first before I write the interval notation. So we put negative 2 and 5 on our number line, circle each, leave the circles open because negative 2 is not included as a solution, nor is 5. Now, all values less than negative 2 would be to the left of negative 2, and then all values greater than 5 would be to the right of 5. Now we have 2 shaded sections on our number line. So for interval notation, we're going to have 2 intervals. What's way out here to the left, that is negative infinity, and negative infinities, our infinities always start with a parenthesis. So parenthesis negative infinity, comma, it's coming up to negative 2. It does not include negative 2, so that's a parenthesis. Or you can write the symbol U in union with 5, comma, infinity. We'll have more practice with this on the next page. So for practice together, find and graph the solution set of the absolute value of 2x plus 3 less than 49. Absolute value is already isolated. Our inequality symbol is a less than, so we're going to draw our two arrows. For our left arrow, we drop the bar, 2x plus 3. We switch the inequality symbol to greater than and negate the 49. Write the word and. For our right arrow, drop the bars and copy as is. Now solve. Subtract 3 from both sides. 2x is greater than negative 52. Divide by 2. X is greater than negative 26. Subtract 3. 2x is less than 46. Divide by 2. X is less than 23. Now let's take those two values, the 23 and the negative 26, put them on the number line. That's just my preference to write it graphically first. Circle each. Those circles remained open because it was simply less than, not a less than or equal to. And we need all values that are greater than negative 26 and less than 23. So we need to shade between these two. Now to write this in symbolic form, we put the variable x in the middle. And reading this from right to left, this would be x is greater than negative 26, and now from left to right, and less than 23. In interval notation, we have just one piece shaded on the number line, and it goes from negative 26 to 23, and it does not include, so it's parentheses, negative 26, comma 23, parentheses. Now next practice problem together. The absolute value of negative 3x plus 14 is greater than or equal to 18. Absolute value is already by itself, so we break it up into our two arrows. Our left arrow, we drop the bars, so negative 1/3 x plus 14. We switch the inequality symbol from greater than or equal to less than or equal to, and we negate the 18. It's greater. I kind of use this trick and I write the word greater, O-R. I know it's spelled E-R, but just for a trick, greater means we're going to write an or between these. And for our right arrow, drop the bars and copy. And now solve each inequality individually. So subtract 14. Negative 1/3 x is less than or equal to negative 32. I'm going to multiply by negative 3. The reciprocal of negative 1/3 is negative 3 times negative 3 x. Now remember, whenever you multiply or divide by a negative, you switch the inequality symbol. So let's make note of that. When multiply or divide by a negative, switch the inequality symbol. So this becomes greater than or equal to positive 96. Our other inequality, subtracting 14, negative 1/3 is greater than or equal to 4. And multiplying by the reciprocal, negative 1/3, negative 3. We're multiplying by a negative, so we switch, excuse me, I forgot my x. We switch the inequality symbol, and 4 times negative 3 is negative 12. Okay, so we have x is greater than or equal to 96, or x is less than or equal to negative 12. Again, I'd like to do the graphic solution first. So I put negative 12 and 96 on our number line. Circle each. Shade them in because of the equal to part. Fill in the circles. Now x is less than or equal to negative 12, less than negative 12, we'd be shading to the left. Greater than or equal to 96, from 96 we shade to the right. In symbolic form, way out here to left, that's our negative infinity. I'm sorry, that's interval notation. So negative infinity to negative 12, close bracket, because negative 12 is included, union with 96, close bracket, 96 to positive infinity. And symbolic form, this is all x that are less than or equal to negative 12, or x is greater than or equal to 96. Okay, now if you would, stop the video and try the next 3 questions on your own. Isolate this. First step, add 1 to both sides. So the absolute value of x is greater than 5. Split it up. Left arrow, drop the absolute value bars, switch the inequality to less than, and negate the 5. Original inequality is greater, or x is greater than 5. Well, this is solved already. There's nothing to do here. Let's represent the solution graphically, symbolically, and interval notation. So over to our number line, negative 5 and 5, circle each. Less than negative 5, shade to the left. Greater than 5, shade to the right. Symbolically, we have it already. X is less than negative 5, or x is greater than 5. Interval notation, we have 2 shaded portions. So our interval notation, parentheses negative infinity to negative 5, parentheses, union with, parentheses 5 to infinity, close parentheses. The next example, number 2, again, isolate, so subtract 3 from both sides. The absolute value of 0.1x is less than or equal to 2.4. Split it up into a left arrow and right arrow. 0.1x, switch the inequality symbol, is greater than or equal to negative 2.4. The original inequality is a less than, so this is an and. 0.1x is less than or equal to 2.4. divide both sides by 0.1, and we have x is greater than or equal to negative 24, dividing by 0.1, x is less than or equal to positive 24. So we replace negative 24 and positive 24 on our number line. Circle each, fill in the circles because of the equal to part. And it's an and, so ands you're going to be shading in between. Greater than or equal to negative 24 and less than or equal to 24. Symbolically, x is between negative 24 and 24. Integral notation, bracket, negative 24, comma, 24, bracket. And the last question here, the multiple choice question, which of the following inequalities has the null set or the empty set as a solution? The absolute value of x is greater than 2. The absolute value of x is less than 2. The absolute value of x is greater than negative 2. Or the absolute value of x is less than negative 2. Choice D.